Blockchain networks have to have some kind of network among its participants for them to exchange value, authenticate the same, and also make a record of such an exchange. That is where peer-to-peer network comes in. A peer-to-peer network, abbreviated to P2P, is a very important part of how blockchain technology works and why it is so solid and secure. Here, we will explore what P2P is and why it is such a vast improvement on the centralized systems we are familiar with today. In a P2P network, the user utilizes and provides the foundation of the network at the same time, although providing the resources is entirely voluntary. Each peer is considered equal and are commonly referred to as nodes. A peer is nothing but a computer system on the network. A peer makes a portion of computing resources such as disk storage, processing power, or network bandwidth directly available to other participants without the need for any central coordination by servers or stable hosts. Despite all nodes being equal, they can take on different roles within the blockchain ecosystem, such as that of a miner or a full node. In the case of a full node, the whole blockchain is copied onto a single device, while the device is connected to the network. What this means is that information stored on a blockchain cannot be lost or destroyed, because to do so would mean having to destroy every single full node on the network. Therefore, as long as single node with a copy of blockchain exists, all the records will remain intact, providing the possibility to rebuild that network again. Let us compare the P2P with centralized networks. Peer-to-peer networks completely differ from the traditional client-server models that are common today, as there is no central point of storage such as a server. Instead, information is being constantly recorded and interchanged between all the participants on the network. This is also different to a centralized server model that slows down when more users join it, as a P2P network can actually improve its power with more devices or nodes joining the network. This method of transferring information is a huge improvement because data is not held in one centralized point, making it far less vulnerable to being hacked, exploited, or lost. No central point of storage means there is no need for a dominant authority, and therefore no single party can control and use the network to push its own agenda. Instead, the user becomes the true owner of their personal data as long as they secure it properly. This is a bold step away from the centralized systems of today, wherein a social network becomes the owner of all the data that the user uploads. WhatsApp and Facebook are classical examples of this behavior. Even a company that provides payment systems deciding when you can access your own funds, reserving the right to freeze your money whenever they see fit, is a classical example of centralized system where, despite you being the owner of your data, you do not have much control. P2P networks are a key promise of blockchain. An important derivative outcome of blockchain technology is laying out and propagation of peer-to-peer networks that cannot be taken down, a feature also known in crypto circles as being censorship resistant. Just as the internet is that unstoppable mega network, these smaller networks are supposed to run forever and ever due to their centralized architecture serving as a base foundational layer. We need to understand these peer-to-peer blockchain networks as living organisms. They are in part technology infrastructure and in part social architecture, because they rely on humans who have to first agree on cooperation as a key success factor for their ongoing evolution. These networks depend on the commitments of a large number of participants, also known as nodes, to contribute a variety of resources that are later consumed by users. Some of the known P2P examples are BitTorrent. Number of nodes are countless, though non-blockchain. Bitcoin, 10,000 nodes. Ethereum, 9,900 nodes. OpenBazaar, 18,000 nodes per month. Zcash, 173 nodes. IPFS, 2,000 nodes. These numbers appear small related to the overall sheer size of the web and their true potential, but they are large enough to depict a real and valid direction for this trend. When you peel some of the layer of these peer-to-peer networks, 4 important characteristics jump out. The number of nodes is self-growing and onboarding is typically permissionless. Each node is self-incentivized, which means the economic model should reward nodes. The overall progression should be self-governing, ensuring resiliency and survivability. A degree of anonymity is typically inherent that makes it difficult to pinpoint single origin of work. There is a need to emphasize that incentives are a powerful sustainability factor. Incentives ensure the long-term viability and self-sustainability of the network while making it even more resilient. And a distributed self-governance makes the network more anti-fragile because it doesn't depend on a single entity or person to dictate its evolution. Let us summarize the advantages and disadvantages of peer-to-peer network. Advantages would be P2P architecture is more secure compared to client-server. For instance, by having no central point of failure and having a large number of nodes distributed across the network, denial of service attacks are not possible. Another benefit is data immutability, where the data once is written cannot be altered. The bigger the network, the less chance it can be altered. To alter the data, the majority of nodes need to be controlled by one entity to carry out a 51% attack. Blockchains with the use of P2P architecture are now capable of running independently without any censorship of central authority. In comparison, the banks require complete control over your information and they can also restrict you from doing a transaction if they want to. One of the most significant disadvantages of the requirement of computing power. This is because there is no central server and each node acts as both client and a server. There is no doubt that by using this approach, there is improved security and efficiency. Still, it comes with drawbacks such as lack of widespread adoption and scalability. Another limitation is hard fork events. We discussed that while going through the history and evolution of Bitcoin. Even though blockchains are secure, they are not 100% secure. This means that it can be hacked and anyone can modify it. The hard fork event also means that anyone can take a copy of the data and modify it according to their requirement, thereby creating a new chain of parallel networks. But then, like any technology, evolution is a constant theme and issues are identified and resolved.